All right, terrific. Well, thank you everyone for joining us. I know we'll have a lot of folks that'll be coming in and out over the next couple hours. The purpose of today's presentation is to provide a recap of our recent observability capabilities that we've announced over at re:Invent. And we're really excited that this presentation over the next couple hours will be led by a group of industry leaders and product experts at AWS. So what we'll do is I'll kick off for about 15 minutes just to give a high-level overview of AWS Observability. From speaking to the customers across the US and North America, I found that a lot of customers, even today, are not aware of what they can do with native tools. Yes, so really exciting stuff that we've done so far, and we're really excited to have the chance to share with you what we've done to date. And then after that, I have some technical leads, from the organization that will cover in more technical detail some of the announcements that we've made for observability, from not just a presentation, but also from a demonstration point of view as well. So lots to cover over the next couple hours, and really excited that you're investing the time to learn about this topic. Now let's meet the dream team. I will kick off the presentation for the first 15 minutes. I'm Michael Wishart. I'm the go-to-market specialist for observability and governance services in the NAMR region. So really excited to kick off this discussion and provide an overview of what's available with AWS today. And I'll let my colleagues introduce themselves as they get to their respective sections. But Bobby, Kevin, and Amaya, they're all industry leads and technical leads for our observability services at a worldwide level. So we're really excited and honored to have them join us to give us a firsthand account and review of what's available today with observability services. And really cool, we're seeing a lot of folks coming in now. So I think we're getting a pretty good attendance for this event, which is exciting. So let's get right to it. As I'm sure everyone's aware, no matter how well you design your IT architecture and instrument your observability applications, I think it's safe to say that no matter what, everything fails all the time, as illustrated by Werner Vogels. And so at AWS, we do our best to try to help ensure that this is mitigated as much as possible, because as customers can reduce that mean time to resolution, it makes it easier for customers to move to the cloud and receive the benefits associated with cloud technologies. And so I think a lot of our customers, find themselves from an observability and monitoring perspective, having their operations something like this, where it's almost like an operations room where you have folks from different teams, whether it's the infrastructure team, the application team, or the front-end experience team, and they're all using their own different tools. And when you have that kind of situation, we find that it becomes very difficult to correlate the different types of telemetry data, and which can make it very challenging to identify the needle in the haystack and reduce that mean time to resolution as an issue arises. And so for that reason, we at AWS, we try to help customers ensure that they maintain operational excellence. I'm sure everyone here is well aware of Amazon.com and the operational rigor that we have on the retail side of the house. But we try to apply that same level of expertise and effectiveness on the AWS side of the house as well. And so we've developed some internal tools that help our developers with Amazon.com to ensure operational excellence. And we want to take those tools and help our AWS customers benefit from those services as well. So we're really excited that the services that help the applications and infrastructure for Amazon.com on the digital side can be leveraged by our customers for AWS to help them scale and operate at the level of efficiencies that they need across not just the AWS environment, but also on-prem and other cloud providers for them to be able to operate effectively across the different layers of the technology stack. And we try to do that across a variety of ways. So first is with application monitoring. So we're increasingly investing in our ability to help simplify the performance for customers to get application level observability and to be able to get that within seconds and reducing the effort it takes to instrument the observability tools for those use cases. And secondly, you're as well aware of machine learning. We like to think that Amazon and AWS as a whole has been a leader in machine learning capabilities for the past decade, if not more. And so we are very excited to be able to further invest in our artificial intelligence capabilities to help customers, analyze large, complex data sets, detect anomalous behavior, as well as being able to incorporate newer generative AI capabilities to make the developer experience a lot easier. And we're excited that, with these new capabilities and new native services on the observability front, you can gather telemetry data across those metrics, logs, and traces to help customers reduce the time to manage their operations and be more efficient. So when we think about these tools, we think about this concept of mean time to resolution. And mean time to resolution is composed of three parts. The first part is the detection, the time to detect that an issue has occurred. And the second part is the time to investigate and identify what that issue is. And the third part is to eventually remediate that issue. And so we're really excited that with our native tools, which we'll go into in a second, we will help customers be successful moving into the cloud by helping them leverage native tools to reduce that time to detect what an issue is, to detect that an issue has occurred, to identify and investigate what the issue is, and then with increasing levels of machine learning and generative AI, being able to more effectively remediate the issue altogether. So we're really excited that, by being able to help customers reduce the detection, investigation, and remediation time, you can ultimately reduce that mean time to resolution, which can help not only your developers feel more at ease and successful operating the cloud environments, but being able to provide a better experience for end customers with industry-leading digital technologies and application performance. So this is my last slide for those of you that are just joining. This is the last slide that I'll cover that provides an introduction of observability at AWS before we kick it off to our industry leads who will be diving into more detail related to our re:Invent announcements. So bear with me for the next 5 minutes and we will get to the fun part of the presentation. So there's a lot to digest in this slide, and feel free to reach out to your AWS contact if you want a follow-up discussion in more detail. But what we wanted to do is at least give the visitors of this session the opportunity to understand that, at AWS, we want to provide an option for customers to leverage native tools where possible to reduce that mean time to resolution. I'm speaking to a variety of customers that are, B2B, B2C technology companies, or large-scale enterprises or startups. I find that a lot of customers are leveraging 3 or more tools across monitoring infrastructure, application, the end user experience, as well as their internet network to ensure uptime of their applications. And as I previously mentioned, when you're using 3 or more tools, it can be very challenging to correlate that telemetry data, as well as being able to reduce that mean time to resolution across different teams. So at AWS, we have this breadth and depth of observability services to help customers being able to meet their observability objectives and minimize that mean time to resolution with a single vendor that is also your trusted cloud provider. And lastly, these services, we're increasingly investing in our ability to support not just observability for AWS environments, but also for hybrid and multi-cloud environments as well. So diving into this slide at a high level, as you can see, there's a lot to digest here, but just want to call out a couple of points. So with observability, as you can see on the left side, it's important to gather the 3 types of telemetry data. One is logs, which is that timestamp data for recording and auditing purposes. Secondly is metrics, which allows you to understand the performance of your applications and systems over time. And 3 is traces, to be able to identify a particular transaction and understand the upstream and downstream dependencies that are impacting that particular event. So we're really excited that with our CloudWatch agent, which can aggregate logs and metrics, our X-ray agent, which can gather traces, as well as our AWS distro for OpenTelemetry, affectionately known as ADOT, which is OpenTelemetry compatible with logs, metrics, and traces for those that want that OpenTelemetry standard. We help customers gather these types of telemetry with a single vendor and a single platform. And so with our observability services, we categorize them into two buckets. On the left-hand side, we have our native services, which provides that third-party software experience aligned with your AWS platform. On the right-hand side, we have the open source managed services for customers that have a preference for open source tools, but want to offload the management of those services to AWS to make it easier to operate. So focusing on the left-hand side under native services, we have container insights. We have lots of customers that are focusing and modernizing their efforts onto EKS for Kubernetes or ECS container environments or Fargate. And with container insights, we've made a lot of improvements to help customers monitor their container environments at a much more granular level with an out-of-the-box experience, something that my colleagues will go into deeper later this session. Secondly, we have Lambda insights to get greater visibility into your serverless environments, and then contributor insights to understand performance or understand what is impacting the performance of your applications and aggregating that by the top contributors. You have metrics, which provides an easier querying experience for your metric data, as well as application insights, which provides customers ability to monitor their applications and get that application level monitoring experience. With application insights, we've also made great improvements in this area as well, which we'll touch on later in the session. We're continuing to invest in our dashboarding capabilities as well as our ability to alert and providing customers an easier experience to analyze this telemetry data with CloudWatch and X-Ray. And then finally, on the native services side, really excited that we're making a lot of improvements with our logging capabilities to help customers centralize their logging needs with CloudWatch, as well as the ability for customers to understand the performance of the end user experience with RUM and synthetics, which provides real user experience monitoring, as well as the ability to simulate how the end user would experience your applications before you deploy them in production. And with internet monitoring, you can understand if your applications are impacted by external ISP networks, which can help further reduce that mean time to resolution. And with CloudWatch Service Lens, you can put all this information together with native services, your logs, metrics, and traces on a single platform for you to be able to identify the issues, see how your applications performed over time, and understand the upstream and downstream dependencies to help you reduce that latency and mean time to resolution with native services. So a lot of improvements we've made with CloudWatch and X-Ray, and we recognize that customers may have a preference for open source tools, which is highlighted on customers. I think over 60% of enterprises, if not 70% or more, are using Prometheus today to monitor high cardinality metric data across their Kubernetes environments. However, they have issues with scaling those self-managed Prometheus clusters as they grow their business or as their usage of Kubernetes scales, as well as understanding the cost of their Kubernetes environments as well. So to that end, we have Amazon Managed Prometheus for customers that want to offload the management of their Prometheus tools to AWS while reaping the benefits of Prometheus. You can query on Amazon Managed Prometheus with PromQL, so there's no change in the user experience. And it is designed for massive scale. We have a strategic customer this past year that was able to scale up to 500 metrics with the Amazon Managed Prometheus, 500 million metrics with Amazon Managed Prometheus. So a lot of exciting improvements that we're doing to help large customers benefit from this service. And then just to tie onto that, we have the OpenSearch service for customers that want to aggregate logs, as well as the Jaeger service for customers that want to leverage tracing either with Jaeger or with OpenSearch. And then lastly, from a dashboarding perspective, customers are increasingly using Grafana for dashboarding, but similar to Prometheus, it's a challenge to manage the underlying infrastructure of those Grafana dashboards. And so you can offload the management of that overhead to AWS where you get the benefits of visualization with Grafana dashboards while offloading the overhead of those services to AWS. So really excited that with native services and open source managed services, we provide customers with a variety of options for observability to help reduce that mean time to resolution. And we have seen customers use a combination of these services as well, where you can use CloudWatch for your, as well as your Prometheus for your metrics, and then also using X-Ray for your traces, and being able to export that to Amazon Managed Grafana for visualization as well. So there's a variety of options, and highly recommend exploring this with your account teams to see what's the right option for you. And the final point to make is we are continuing to invest in our abilities to do machine learning and generative AI capabilities with these services to help identify anomalous behavior, but also to help improve the developer experience for our customers. And these are all topics that we'll dive into more detail during this session. All right, so now that I've covered a quick overview of AWS services today, time to pass to the exciting part of the discussion. I will pass the baton to my colleague Bobby, who will cover the first third of the reInvent announcements that we've made at reInvent. So really excited that over 60 of you have joined us today. And for those of you that have any questions, feel free to click on the question mark in the bottom right corner of your WebEx screen and type in a question in the Q&A channel, and I'll be sure to monitor it and help facilitate the questions to my co-hosts throughout the time of this discussion. All right, Bob, the floor is yours.
Thank you. Thank you for the intro. So, hey, everybody. My name is Bobby Hallahan. I am a solution architect here at AWS. And today we're going to cover a few of the new recent launches with Amazon CloudWatch. I'm going to focus a good bit on CloudWatch logs. There's a lot of really cool stuff in the space launched this year. But there's a couple other capabilities I'll cover as well. And then we'll jump into a little bit of demo, and yeah, we'll go from there. So we got about 30 minutes for my section. So let's make the best use of it as we can. Okay. All right. So here is the really big one, I guess. And just bear with me for 1 second. Let me just move some of the WebEx overlays off the screen. Okay. So this is probably, I would say, argue one of the biggest launches we had at reInvent this year, for CloudWatch, that is. And this is ML-powered log pattern analysis and log anomaly detection. So a big thing with log data is, one, I guess there's a lot of it. And then two is sometimes it can be hard to, decipher, what's of value in my logs, what potentially is anomalous in these logs. I guess maybe, put yourself in the shoes of, where maybe an SRE, we're a product owner, or, we're running an application and something happened, right? There's some sort of degradation in performance. Maybe we're missing a KPI, maybe, some SLOs are breached, maybe that, or an alarm just went off and we need to know what happened. Being able to see and visualize this easily in log data can be difficult and challenging sometimes. With patterns and pretty much the suite of three new features we launched, it makes it really easy to be able to decipher what's happening in your logs. So I'm going to quickly cover some of the three big launches, right? So first, patterns. What we're doing is we're able to distill down all of your logs into two distinct specific patterns, right? So then you're able to see, of what's in my log group, what types of patterns exist in here. And you're able to use that to quickly identify what's in the logs. But more importantly, what it can let you do is also see, the types of log messages you have. So for example, maybe let's say, maybe I'm looking at like a high spend log group. I could use pattern to understand, what's made up of those logs. Is it info level logs, error level logs? What type of regular expressions are we seeing there? So it's very handy. But then if we add on top of this a compare mode. So this helps you answer pretty much the question, like what changed over time. So then let's say, let's go ahead and compare this set of patterns that we're seeing in the logs today to maybe the previous period, the previous 5 minutes, 10 minutes, 1 day, 1 week, however long we want to. And what it's going to let us know is, are these patterns new? or have they increased or decreased? Essentially, what it lets you know is, are these errors we're seeing new to the specific error? Like let's say if the alarm goes off, right? And we look at our logs. Are these errors? Are these something that's have always been there, right? And there's been just errors that have been, always in our logs, and we just never really looked at. Because let's be honest, there's, logs can be chatty sometimes. Sometimes there's those errors that you don't really look at. Maybe they're not that important, but they're there, and they can throw you off when, trying to investigate your logs. Or is there a new pattern that you're able to correlate with maybe a recent change or a degradation in performance? And then lastly, this last feature is always on anomaly detection. And what this lets us do is on a log group basis, look for specific anomalies based on these patterns. So then what you're able to then do is enable anomaly detection on your log groups and then view anomalous behavior and then be able to view comparison features over time. And what's really nice about this is that this feature is included for free with CloudWatch Logs. So if you're using CloudWatch Logs today, go ahead and check out anomaly detection. And I'll be showing a very quick demo of this as well. Now, let's move on to one of the other new features in CloudWatch Logs. And this is AI-powered natural language query generation. So my assumption here is, we're all here to learn about CloudWatch. I have an inkling that most people here are familiar with CloudWatch Logs Insights. But if not, what it allows you to do is it is an interactive query tool for CloudWatch Logs that lets you deep dive into your log data. It uses a pipe delimited language, and I think there's like 7 or 8 different commands with a whole bunch of available subsyntax. However, what Logs Insights does, the query language can be tricky, right? Let's say we'll put ourselves back in that same example where, maybe we don't necessarily know what the error is. Maybe, there's an alarm going off and we need to try to figure out what's happening quickly. What this can do for us, and I'll actually replay this video again. What this can do for us is allow us to quickly ask something in plain text and get a query back in response. Now, this can be used as a couple places, right? If you're not familiar with the Logs Insights query language, you can get something immediately. So it can be used to help you in those stressful positions, but it can also be used as a learning utility as well, because you have the ability to generate new queries and then update queries as well. So you can then iterate on the responses and results in your queries. Right now, preview is available in US East and US West. And this is also something I'll be able to show a very quick demo of as well. Okay, now the very last big announcement with CloudWatch Logs is CloudWatch Logs infrequent access. So when we think about CloudWatch Logs and we think about, let's be honest, cost controls, CloudWatch Logs can get expensive. Let's be honest about it, right? US East 1, 50 cents a gig for ingest. That can add up pretty quickly. Now, what we've done over time and what the service team has been able to do is, there's a lot of features that have been released over the years that can help, justify that cost, right? You have metric filters, you have contributor insight rules, you have anomaly detection, you have PII detection and redaction, subscription filters, a lot of different capabilities on top of everything we just covered in Logs Insights, to help, maybe justify that cost a bit. But let's say if I talk to a customer and they say, you know what, I'm really not using any of those features. But for, maybe I need to keep my logs for a compliance use case, or maybe it's something where, I just got to query them every once in a while. For some customers, it was hard to justify that cost if you're not using any of those features. So our service team went ahead and built a brand new ingest path for CloudWatch Logs. And what I mean by that is under the hood, we're ingesting the logs differently, right? From a customer standpoint, right, it's still the same put log events API. You just define this in the log group setting. So you say, hey, I want my logs to be infrequent access. And what that's doing is, we're ingesting the logs differently. And because of that different ingest pattern and path, while we do cut some features, on top of that, we're able to offer significantly lower pricing. And by that, what I mean is essentially we're cutting it in half. So in US East 1, standard logs are 50 cents a gig. With infrequent access log class, that goes down to 25 cents a gigabyte in US East 1. So right there, essentially, we're just cutting that cost in half. This price reduction is also extended to vended logs for that first tier of usage too. So if vended logs is something that's becoming to be pricey, you also have the option to use infrequent access log classes there as well. Okay, but let's talk turkey. When I said a different ingest path, and I said, okay, you're not gonna get every single feature from logs, but you'll get a couple of things. What is that? So let's actually jump in and see what you get with which one, right? So everything we still get with infrequent access, right? So fully managed ingest and storage, right? So the same put log events API works, right? Everything you use from your SDKs to write logs, everything you use with the CloudWatch agent or OTel collectors to write logs, all that still works just as it was, right? This is just a setting you toggle on the log group creation. Cross account still works. So if you're using cross account log metric and trace data, cross account data still works with infrequent log access classes. We still support the same security standards with AWS KMS. You can use an AWS managed key or a customer managed key. Logs Insights also works. So then you're able to query your log data just as you would with any other log, with just the standard log classes, just with Logs Insights. And of course, that works cross account. But let's talk about what doesn't necessarily work, right? And this is where we talk about log anomaly detection, live tail, metric filters, and extraction. On top of that, that also means subscription filters. And data protection. So you are, we are losing some features here, but because we're ingesting the data differently, we're able to offer a lower cost. So something where when we think about helping our customers save money, this could definitely be a feature worth looking at. If cost optimization is a path you've taken earlier last year, and you want to take another second pass at it, I would say so, right? Take a look at your CloudWatch log data. Look, it's like, hey, ask yourself, are we using these features that are offered in standard? Can we use these features to get more value from our logs? And if not, maybe logs and frequent access is a good choice. So definitely, if there's an action item to walk away from in this session, I would say this could be one of them. All right. So when we talk about which ones to use, right? Standard real-time operational visibility, advanced analytics, infrequent access, right? As needed for forensic analysis, right? This gives you that core logging capabilities for infrequently asked logs. All righty. So let's move on to our very next topic here, which is CloudWatch multi-data source querying. So this one's pretty neat. And what this allows us to do is, sometimes when I like asking this, I like doing a poll, right? But I'm not sure if we have that interactivity that we can set up here. But I'll still ask the question, which is, how many of you here have metric data, right, or time series data stored in a place other than CloudWatch? And I think it'd be fair to say that most of us, right? Either OpenSearch, Prometheus, right? Maybe we're using a different cloud provider like Azure or Google, or maybe it's who knows where, right? Maybe I'm using my own time series DB. Yeah, there's in large organizations, it's all over the place, right? But that's been a challenge for our customers, right? If I walk into a customer and I say, hey, you can use CloudWatch, it's like, hey, well, what about the data in OpenSearch? Or hey, we got Prometheus data over here, or maybe there's something in a different cloud provider. We couldn't really say you could take a CloudWatch approach to this. Well, as of today, now you can. Because before that, right, like Grafana was very, very popular and works very well that way. This operates almost like that. And what it lets us do is we can create and define different data sources in the CloudWatch console by using a Lambda connector. So there's nothing like super duper fancy here, but we are using AWS Lambda, so we have some pre-built connectors, but then you can also bring your own. And in our demonstration, I'll show a couple exciting things you can do here. But for example, we can define our data source name. In that case, we're using a workspace. And if we want to use a VPC or not to actually be able to access that resource. Okay. And then, of course, with the custom Lambda connectors, I'll actually show a little bit what that looks like. You can do some pretty neat, pretty slick things. And what's nice about this is that we're not just doing a rendering of metric data, right? We're being able to do a render. We're able to leverage math expressions too. So we can then combine this data telemetry. Like we can take our metrics from Prometheus, combine them with a metric from CloudWatch, and then alarm on the result of that. So it's much, much more than just being able to show a metric from somewhere else, right? Where we're being able to then combine it and leverage all the other features of CloudWatch metrics. So without further ado, let's go ahead and jump into some demo. I got about, yeah, okay. So we got about 15 minutes, and let's cover a couple cool things in log anomaly detection. And I'll show you just a pretty simple workflow of like where this can be valuable, right? So let's go ahead and I'll close out the sidebar here. But what you'll see here, right, is we have log groups and log anomalies. So you have a dedicated page for log anomalies. You can see it based on anomaly detection patterns. Maybe I want to look for specific log groups. And then I can see things like the anomalous behavior, the log pattern, last detection time, and I also have a user-defined feedback here I can provide if this anomaly is accurate or not. How we go about enabling log anomaly detection is fairly straightforward too. So within our log group selection, we can just go to a given log group, and then we can go to the anomaly detection tab, and then just hit enable anomaly detection. But now let's say we're investigating an anomaly, and we'll go ahead and say, let's actually check this one out. So we can see that we have a specific pattern that's been found for a given method. We can see examples of the actual log message itself. And then we have a couple tokens here as well. So we can see those tokenized values. Now, what's neat about this is from here, we can even jump into Logs Insights. And what this allows us to do is in Logs Insights, I can analyze that specific pattern. Or let's say, maybe I'm not familiar with this log group and I want to learn a little bit more about it. Just by running this stock standard default query we get, right? And we can take a look at these log messages. And I'll zoom in a bit here for everybody can see. In this message field, right, you see there's a whole bunch of stuff here, right? We get some, looks like a server access log. We get some JSON type stuff. Looks like there's some health checks here. But there could be other things I may be missing, right? This is where patterns can come in really great handy because by using patterns, I'm able to distill down. It pretty much looks like 20 specific or unique patterns from a sample set of about 4,000. And we can see we have severity levels, event ratios. So it looks like in this case, about 30% of my logs are health checks. But then I can scroll down and see if I can find info or type of errors. But let's go ahead, just to be safe, we'll hit analyze all records. And if you noticed, what we've actually done here and what the console's done is it added this pattern command. So it's pattern at message. And the big takeaway here is that what patterns is doing, it's not like a console trick. This is something that's built into the Logs Insights API. So if you're using Logs Insights today, you have access to pattern immediately. So all we need to do is rerun the query. And then now this gives us a pattern of the entire log group of all messages within the last hour. And now we can see we get a much more better representative example of what our events look like. And then let's say maybe we want to take a look at a specific pattern. From here, we can see, and I might zoom it out a bit so it doesn't get as crowded, but we can see token values, any patterns that are related to this one. But then more importantly, we can go and check out that compare feature. So for example, I can compare it to the previous period, being 1 hour, previous day, week, or month. And then we can compare. And just like what we did with pattern, you'll notice that diff is now included, which is featured as compare, right? So this is, once again, this isn't some funny thing we're just doing in the front end console. This is a capability that we're exposing directly through the Logs Insights API. Of course, we're rendering it pretty nice on the console, but this isn't something that's only available on the console, right? If you're using the API, you have access to get the same data. Now, let's go ahead and take a look at the results. Here we can then see difference descriptions or variants of different patterns over a period of time. So now we can see this specific pattern is decreased by 26% compared to the previous period. And we can see a time series comparison of this as well. Now, let's go ahead and we showed a little bit of the log anomaly detection. We've shown a bit of pattern and diff and compare, but let's go ahead and jump into using our query generator. And what I like to show for this is actually taking a look at CloudTrail data. Mostly because, for the most part, this is an assumption I make, but if we're operating in AWS, I like to think that most of us are familiar with at least what CloudTrail is or the types of log data we get from it. But what's nice always, right, with logs insights, with any JSON type log, we will do log field detection. So we'll do field extraction, meaning we can call these fields, sort, aggregate, filter on these specific field names and the values of those fields. But this applies for any JSON value, not just vended logs coming in. But on top of that, what we're able to do, so if you want to get familiar with what the CloudTrail looks like, there's plenty of examples out there. But let's say in this case, maybe I'm looking for something specific, right? KMS. I can say, hey, find me KMS API calls, and I can say include the prompt and the explanation, and generate a new query, right? So maybe I don't know, let's say I don't know anything about logs insights, but I'm tasked with finding something specific. And we get something pretty bare bones here, right? So filter, event source, KMS. So at least I know what the filter means. And we'll go ahead and run this query and see what it does. And here we can see our logs. And yeah, okay, here's a bunch of logs. Now, let's say maybe that's not exactly what I'm looking for, right? Maybe I say, hey, you know what? Actually group this by the API call. Don't just show me them. I want to show them and then group it by the API call. So I can actually use the update query to then say, you know what? Now what it's done is added that stats command. So stats count star as hits by event name. So now what I've just learned is I'm learning how it's referencing different field names. I'm learning how to use the stats command and then use an ephemeral field and renaming fields here. So let's go ahead and rerun this query then. And then now I can see, you know what? It looks like most of these API calls are generate data key. Right? So then say, you know what? Instead of KMS API calls, find me KMS, maybe generate data key API calls, and then maybe group by the key name, region, session issue or username. So now I want to see, okay, I know that this API call is happening most frequently, but maybe show me this by the group, the key name, region, or session issuer, right? And now look at this query. So now we can see we're selecting specific fields like the region, request parameters, event name, event source, and then we're doing some grouping here. So let's go ahead and run this query and see what it gives us. And then now what we're able to see is the region, the user identity invoked by, the request parameter key IDs, and then, you know what? So I see it's US East 2. It looks like it's happening most, but then maybe the key ID isn't so friendly. So maybe I want to see the key, ARN, and then the role ARN. Because it looks like most of this is happening in US East 2. So then, and we know it's happening for S3 objects. So maybe maybe we're using KMS for S3. And now what we can see is we gave us a different, slightly updated query. And we can rerun it. Oh, wait, did I actually ask it to update the query? I'm not sure if I did. There we go. And then from here, by being able to iterate on these types of queries, you can actually build some pretty powerful stuff. So in this case, I'm actually going to show you a query. By kind of using this example, we can see where we have things. In this case, right, we'll actually just rerun this query. And by using and kind of iterating on the query generator, I was able to actually build something relatively complex, right? Where in this case, we're being able to get the requests by KMS key ARN, the role name, so who called it, the key alias, and then the cost for the key. And we're able to do that by just doing, taking the count of requests and then just doing the math expression of how much, the request costs for KMS are. And then in a 1 hour period, now I know how much a given key ARN is costing me and for what these look like synthetic IAM roles. So I know the service and the key ARN that's calling this. Of course, plenty of other examples out here for using logs, insights, and query gen, but definitely check it out. It's super helpful, very, very handy if you're not very familiar with the query language, and allows you to get started very quickly. Now, let's go ahead and check out a couple other things before I break here. Now, one other note here is, and this wasn't a reInvent launch, but I think it's something that's worth including. So we'll jump into our log groups, and we'll go in and check out. So once again, right, I'm assuming that a lot of people here are pretty familiar with CloudWatch logs or CloudWatch in general. So you're familiar with the concept of a metric filter, right? And this is where we define a filter pattern. And once that pattern matches our logs, we publish metrics, right? Those metrics we can include dimensions in those metrics, so we can create a dynamic number of metrics from a given pattern. We can take the value from a field and publish that in the metric. But then, generally speaking, right, our metric filter patterns have been, pretty much isolated to just JSON data, right? And we'll do some simple string matching, but if your logs weren't in a JSON format, it made it, this feature wasn't as valuable. But what we launched actually right before reInvent is regex support for metric filters and subscription filters. So now I can use a regular expression, in this case, right? I'm maybe looking for an HTTP status. Within my metric filters. So now if you have data where normally you wouldn't have been able to use a metric filter before, definitely check it out because this is a like a low-key, super duper powerful feature. Yeah, it can really help redefine a lot of the things that customers may have not been able to use metric filters before, and now they can. All right, so lastly, moving on to and jumping into metrics is our multi-data source query. So if we're familiar with CloudWatch metrics, insights, this is where we're able to, query our metrics based on a metric namespace, metric name, filter, group by, and limits. But I can also bring in data from, let's say, Amazon Managed Prometheus, right? And I can have a query helper here, right? And I can build a POM-QL query and actually run that. Or maybe I can actually do, in this case, is a custom metric where I'm creating I'm actually comparing metric data points from period over period. So take some metric and then I want to compare it to, this same metric from 7 days ago. And I want to be able to do that. That's something we can do with multi-data source. But let's go ahead and see what it looks like to create and manage a new data source. So in this case, just like you saw on the slide, we can click from specific things like OpenSearch, Prometheus, RDS, a custom template. But let's go ahead and look at our custom template. And here, not can we just do, we can do things that you may have not been able to do with metrics on their own, right? So I can do multi-region searches, time shifts, moving averages, histograms, different types of visualizations, or really anything that you can do with Lambda that you weren't able to do with just a metric math expression. Now you can do with these custom data sources. On top of that, we'll also be able to query metric data from other data stores as well. So now, this is a multifaceted feature that has a lot of flexibility in how you can use it. But with that, kind of covers the content and topics I had for today. And I'm going to go ahead and pass it off to my colleague Kevin, who's going to walk us through a few of the more recent launches with CloudWatch.
Perfect.
Yeah,
Thank you,
thanks,
Bobby.
Bobby.
And quick call out, Kevin, before you get started. Just for the group, I'm about to share in the Q&A a link to a survey, recognizing that some folks might need to drop off at times over the next hour. But if before you do, we enjoy doing these presentations, so feel free to provide your feedback to the link, and we would really appreciate that. Thank you.
All right. Yeah. Okay, let's get started. Nice to meet everyone. My name is Kevin Lewin. I'm a senior specialist solutions architect, also on the observability team, with Bobby and Michael and Amaya, who you'll hear from next. And today I'm going to talk about a few recent releases. Some of them were at reInvent, some were slightly before. But basically, I have a few small kind of UI UX quality of life things to show. And then, towards the end, I'll go over kind of one of our big APM launches, which is called Application Signals. But what I'm going to start with first is something that came out last year and is a really nice kind of UI thing that we now offer. It's called Dashboard Variables. So I'm going to assume everyone's kind of familiar with dashboarding in CloudWatch, right? You can pull up any metrics, you can pull up log insights, queries, traces, all of those things. And Bobby kind of was just getting into some of that. But what we offer now is the ability to kind of make these more interactive. You can kind of think of it like kind of like a pivot table in Excel, or Grafana has this feature where you can have variables that basically get inserted into the queries that you run against your data. And then we'll, of course, change what you see on the screen here. And I'm kind of showing this here. So right now I have a CloudWatch dashboard. This is a graph of the duration of a Lambda function in milliseconds. And we can go and we can even just see here what exactly it is, right? So I have the duration metric for this one specific function, right? And that's great. Okay, so it's nice that we can do this. We can make these widgets, but what if you have 35 different functions, right? Are you going to make 35 different widgets? It's not a very efficient use of space. So what we offer is the ability to create variables that you can kind of just then click through your different, in this case, functions. And I'll show you just kind of what it is to create that. So we can just go up here to actions and we can create a variable. So you can do two different types. You can kind of do a property variable, which is just basically getting at kind of your CloudWatch namespace dimension properties. Or you can create your own with regex. That's something you can do. But for this, I'll just do a property variable. And I'll go down to my function name, which is the dimension that I have in my current widget. And there's three different types of input. So you can do text input, which is, of course, you can just type in the function and then it'll come up. You could do radio button, which is great if you just have a few values. But I think what I'll do is a drop down. And then you can either create your own list because, maybe out of 50 functions, I only want to display 10 in my dropdown, right? So I could easily just kind of name them here explicitly, or I could use the results of a metric search, which is what I'll show you here. So of course, with the metric query, you can get at any namespace and metric, and you can filter and group by the different dimension values. We have a lot of pre-built ones for a lot of common things you might want to do, and for me, Lambda function and duration is actually one of them that's already there. So I can just go and pick that and populate it. We can see what it does in the editor, right? This is the actual query it's running. And then I can just go to search. And I can see that, by the dimension function name, I have 16 unique resources, and we have a preview up here of what the variable will look like in our dashboard, right? So here's all my different functions now in that namespace. I can just go and hit create variable. And so now I have this, which was for my original function that I defined, but now I can go and I can just easily click on any of these other functions right here from the UI. Right, so this is quite a nice thing to create kind of these more interactive and meaningful dashboards to you. Because we always say that like a dashboard that nobody uses is pointless, right? You want to really take some time, make these usable. Doing things like this and adding text and labels could really mean a lot to your kind of overall experience there. So these dashboard variables, they're a fantastic feature. It's one that I've wanted a long time as a long time Grafana user. Like I always loved that functionality. And, we have those here now. Very nice and simple to get started with. The next feature that I'm going to talk about is it's kind of a new UI UX for setting up metric streams. So you've always been able to, like, metric streams are very common. For those who aren't aware, metric streams allow you to basically stream metric values out to third-party destinations or to something like an S3 bucket. So this is very common when people are using like third-party, partner vendor observability solutions. Think of like, your Splunk, your Datadog, AppDynamics, all those things. A lot of times, either they are pulling our service for metrics or we can configure to stream them to there. It used to be you would just kind of go and you could select like a specific namespace, or you can just choose to like stream all metrics, but we added a lot more control over that. And it may seem like a small feature, but this is actually pretty important because let's say that I want to send, EC2 metrics to, whatever, my S3 bucket, but maybe I don't want to send CPU credit usage, right? Like, let's say I'm not using burstable instance types. Maybe I don't care about CPU credits. None of my important instances are using that. So that metric doesn't matter. So I can choose to exclude that from my stream and I cannot send it. So obviously this is very important for things like cost optimization. Of course, usually with vendor observability tools, you're kind of paying for the amount of metrics that you ingest. If you can ingest less metrics, then you are potentially saving some good costs there. So this was a pretty nice feature for our service team to release, where they gave you just more control over these metric streams, where you can actually explicitly define what you're sending instead of just sending big buckets of data that may not be able to be used. So it's a small feature. That's about all there is to demo, but it's a very nice quality of life tool. The third kind of small thing that I'll go over here, and this I think is great, is we now have alarm recommendations. So these are out of the box best practice alarms, kind of curated by us at AWS. People have been asking about this for like a long time, and it's here, and the implementation is pretty nice. So if I'm looking at all my metrics here, I can go to EC2, and maybe I go to look at my per instance metrics, and then I just hit this little radio button up here to see metrics with alarm recommendations on them. And then once they're there, there's a few things you can do, right? So I can click view details, and it'll basically describe, why this alarm is important. right? What is the justification for it? Like, why are we doing this? And then right from there, I can just create the alarm, right? So it's pretty quick. One click, go to create alarm, very easy to do. And I can also view the alarm source, right? So this is very good for things like integrating into like IAC pipelines, right? Infrastructure as code. We're going to just give you the code required to create the alarm. So you can see we'll give you CloudFormation or a CLI command to create the alarm, or Terraform code, right? So you can very easily implement this alarm into your own kind of pipelines. And then if you just want to take all of them, you can actually just go and download all of them, right? You can say download Terraform for all 8 alarms, and it will then just give you that in one Terraform template. So it's very good to have this because this serves as kind of like a baseline for your alarming. This, of course, isn't going to cover everything. Like you as an alarm owner, you probably have tons of different, maybe like custom application metrics and alarms and things. But this is a really good way to just get a baseline set of alarms applied over for AWS infrastructure. So it's really like, and Bobby was getting on this, this is almost like the log insights query generation. This is a really just kind of like good way of learning even about AWS, right? You may already have lots of alarms and not really need this, but to just be able to see it and the infrastructure as code and the justifications, it's kind of integrating like a learning experience into the console, which I think is quite nice.
Kevin, Michael here. Quick clarifying question from the audience. Is there a way to generate these those alarm recommendations with recommended thresholds as well?
So right now, like it's just at the threshold, that we give you. But if you were to go and then create an alarm, you can set the threshold to like whatever you want. Like we pre-populate it with what we recommend, but you can easily go and change it, right? And insert your own.
Thank you.
Okay. And so the last thing I'm going to go over, and this is kind of slightly bigger functionality, is our a new APM experience. And for those who don't know, APM means Application Performance Monitoring. And this has been a really big focus on our team, is kind of extending observability, not just over like AWS infrastructure, which is what CloudWatch kind of maybe traditionally is known for. But a lot of people don't think about things in terms of like an EC2 instance or a bucket or something like that. They think about applications and services. So what this is kind of a very nice like UI and discovery layer for some things that already existed, like traces and metrics, but also like some new things like dependency tracking and SLOs, right? So this just came out at reInvent. I do, of course, need to preempt this. This is just in public preview right now. So right now you can use this with Java applications and EKS and ECS. It will shortly, be extended to, a lot more languages and platforms. But for now, what you see here is like a Java application running on EKS. And of course, like most applications are composed of multiple kind of services, right? You can call them microservices, but we just call them services. And we're going to see this kind of top line view of all of our services here and their health. And kind of the top operations here. If I clicked into one of these services, we can get a lot of great information. So I can see like all the service operations that this service is composed of, right? Like my API is composed of all of these things. These are all client requests that have come in. and I can see their health, and I could create an SLO directly from here. So for those who don't know, an SLO is a service level objective. And basically what this means is we're kind of setting this aggregate value, and we're not going to take actions unless we're not meeting that service level objective for a certain metric or what we call SLI. So for instance, like an SL, I can view this and see all the SLOs on my operation, which is these are my GET requests to customers and owners, and we can see the status here. And what we think of with these is something like an error budget, where the latency being high for one request is not worth waking up someone over at 3 a.m. So you kind of have this budget of errors, and you're only kind of setting off alarms and considering something unhealthy when your error budget has been used up, right? So you start with 100% of your error budget, and then that, as your threshold is breached, it would go down. And we can kind of see these types of top line metrics here and what we're doing with those. So that's kind of the experience of the SLO itself. Now, if I were to look at this service, I can also see dependencies, which is very nice. So these are the dependencies of the service, like what it's talking to perform its functionality. So this service, my front end of my application is calling on these various different other services to perform things. And I can easily see, what's going on here through all of these. Okay, and if I were to go and click at a certain point, I can see the traces from there, right? So here I have some faults building up in my tail P99 latencies. And then I can go and just pull up a correlated trace. And I can see that exact request, right? So this is a call to a SQL backend, and we can see, how the requests move throughout our services. And then also, this was the original service I was in, but now I'm able to see that the bottleneck was actually in this backend service, right? So I can go and click on my fault, and I can actually see the exception that bubbled up from that, as well as an overview of what this was doing. And it's quite nice to kind of go from this, like, my error budget is running down. I'm going to click onto my service. I'm going to see a certain dependency that is presenting the problem, and then I'm going to go into a specific trace and see like an exact exception bubble up from there. So this is kind of meant to be this kind of like full stack drill down experience for your applications. And with this, we have a new redesign of the service map. So if you've ever used X-Ray, within CloudWatch, this should look familiar to you, right? It's a service map, but we've slightly redesigned this where now instead of kind of just going by latency, you're going based on whether your SLIs are healthy or unhealthy. You can have that in the legend here, right? So I can see that I have unhealthy SLIs in this microservice. It's pretty easy to go into the operations here. And again, now we're back at that page. So we went from a visual service map, all the way back, and then we can go and see the traces, that had that error. So this is a great way to kind of get this correlation is really what this is all about. It's correlating your metrics, the SLIs and SLOs with the exact traces that drive those SLIs and SLOs. And then we're showing to them visually with one kind of UI and UX experience that you can easily alarm and alert based on. And you can also see in your services, you can see your associated synthetic canaries, right? So if I can go into here, and these are all the canaries I've created for this service, and I can see whether they're passing or failing. For those who don't know, a synthetic canary is basically like a synthetic test of your application, right? So the simplest test is just something like a heartbeat, like a layer 7 ping check. You can also create much more complex synthetic canaries where you're doing actual application workflows, like checking out a product from a store, or actually running these API operations. Like I can see, I have synthetics for creating an item, for updating an item, for just generating traffic in my case. And you can do all these various different things there. Another thing this would do, and I don't actually have this. Yes.
Apologies.
Yes.
And let us know if you want to wait till after, if you want to give a couple minutes for tackling this question. But there's one queue around if there's plans to support OTel in the API gateway besides supporting X-Ray.
Yeah, so as of now, I've not heard.
Kevin, sorry, I just realized we might need to refrain from answering that question, given it's a roadmap and we're recording we're recording the session. So I think we'll have to. I would say for the attendee that asked that question, connect with your AWS contact, and then we can field it that way.
Yeah, awesome. Yeah, so the last piece of application signals is also we're able to pull in RUM data from our front end here from client pages, right? And I actually don't have this set up in my account, but the other side of synthetic canaries, which is synthetic traffic, is real user monitoring. And so we could also pull that into this one viewpoint as well. So overall, to sum things up, application signals is this meant to be this unified APM experience where we're bringing in all kinds of observability signals and data, and we're kind of correlating them and showing them to you in this new UI UX experience, and also providing you some new functionality like SLOs and dependency tracking. So that's about all I have to show today. And with that, I will go ahead and hand things over to my colleague, Amaya, and he's going to show you some things from our open source offerings.
All right, thank you, Kevin.
One last question before Amaya takes over. There was an ask to see if we are able to show an example to use the FX storage latency for your demo, Kevin, if you're able to touch on that.
What was that, FSX? Is that what you said?
Yeah, the ask was, please show example to use FSX storage latency for those. I think it was related to the canary example that I just shared.
Yeah, I don't have FSX set up in this account or workload, but the way of getting at those metrics is going to be kind of the same here, right? You can go in and define them as an SLO or SLI if that was part of your services, architecture. But I can't really show that, right now with what I have.
Perfect.
Yeah, so I'll go ahead and hand things off to Amaya now.
Thank you, Kevin. All right, so I am going to share my screen. Hope, okay. I hope you all can see. All right. So what I'm going to talk about is, first of all, CloudWatch Container Insights. This is not really a net new service or a feature. If you've been following CloudWatch closely, you might remember that we launched CloudWatch Container Insights back in 2019. I believe like sometime late 2019, I believe. And back then, we had EKS and ECS, and we started supporting both the container orchestration platforms, and customers really liked using that, and they continue to give us feedback, and we constantly listen to customer inputs and to essentially shape the product, right? So in terms of making it easier for them to use and adopt our features and services. And in this journey, we learned a lot from customers as to like what they like in Container Insights, what they found to be challenging, and they actually seem to be from different areas, right? So first, customers complained about having to really manage multiple agents themselves. Like they had to, we had a quick start sort of script for EKS, for example, where it could really do the job, like sort of just deploy the CloudWatch agent and the Flow and Bit agent, and as daemon sets and sort of collect the data. But essentially, we stopped there. There is really nothing Kubernetes native happening. It was just another workload that you had to kind of deal with and all that. And customers, while they liked the quick start, but they asked for much more managed Kubernetes native experience. Also, and in the process, we also we collected Cloud Containers by default collects lots of metrics and from different aspects, right? From under different dimensions. The challenge that we faced was that at scale and in certain scenarios, even not at an extremely large scale, it became a little bit of kind of cost prohibitive for customers to adopt the service, and that is another one that customers talked about. And because of that, we also had to drop some of the metrics that we were collecting by default, like container specific metrics. So because of that, some insights were lost, and customers were asking, I actually want to know a container level information. I want to know the CPU utilization, memory utilization at the container level, but you're not giving me how can I get that? And also the third point that customers discussed with us was, okay, this is all good, all infrastructure metrics is all great, but like Kevin mentioned before, in the CloudWatch application insights or application signals presentation, customers look at their resources from application point of view. At least it depends on what team you're talking to and so on. But essentially, they're looking at, okay, my website, my API, then my EC2 instance or my EKS cluster or anything like that. So they wanted that integration with the application performance view and the infrastructure view. All these inputs were considered, and we actually had a really tough problem to solve, right? So customers on one hand were asking for more information to be surfaced, but they were also unhappy with how much it costs them to operate. And this is basically the two opposite things, right? So the more, the higher the usage, the higher, the greater the cost is, which is kind of the normal expectation in cloud services. But in this case, we had to solve this tough problem. So we discussed, internally quite a bit, and we tried to understand how we can solve this problem. And we came up with this enhanced container insights option for customers, right? So I'm going to show how that looks like, right? With this, we have changed the interface completely because we had to surface more information, and also it had to be much more accessible for customers. And like I said, customers were also asking for looking at not only infrastructure metrics, but also application level metrics. So I am on the CloudWatch console. Hope you can all continue to see this. And if I'm going to the Container Insights console here. And you can see that it has actually changed this. I have enabled enhanced container insights on 3 of the EKS clusters that I have. And here it gives a nice visualization of like immediately what is going on in my clusters. You can see that 1 is red. That essentially means that there is 1 in alarm. And I can simply click on it. I can see, again, real quick view of, okay, what is going on? I have an alarm at the cluster level or at the metric that was created at the cluster level. And there are no alarms at other levels, and it tells me that 5% CPU utilization and 32% memory utilization. And you can see that there are 2 other clusters that have low utilization. If I have like average or decent utilization, it would show green essentially. And on the right hand side, you can see a summary of how it is looking like overall, right? So cluster CPU utilization, memory utilization, pods and nodes and all that stuff, right? It gives you this visualization without you having to create any widget. So I basically didn't have to do anything other than simply enabling that. And I already have it, right? I can also dive deep in, like say, for example, I can go to say this cluster and I can go see all the cluster summary. I can click on a namespace. I can get a summary of the namespace or in other words, the metrics and the performance metrics or health metrics based on the namespaces. So you can see these are the different namespaces that I have here. I can actually filter one of these. I can filter, like say, for example, the default namespace, which is where I have all my applications, and I can see all the CPU utilization at the namespace level. I can actually go to specific pods, and I can see total number of containers and all the pods included. And I can go filter. So I can go filter, okay, so default namespace, I want to go with this, all these different workloads that I have. And here I'm selecting one of the workloads, and I can see that, okay, that's the pod there, right? So I can actually select. There's only one. There happen to be only one pod, but you can see that there's the information that is specific to the filter condition that I applied. I can also go all the way down. Now I'm looking at all the infrastructure related details. I can go select here. I can go actions. I can see application logs, X-ray traces, performance logs. I can click on view performance logs. That will take me to CloudWatch Logs Insight automatically. It will select the log group and write a query for me. All I have to do is simply run query, and that will give me all the information that I need, right? And I can also go to this application signals tab, right? So application, now I can actually see that this is a service, and now I can click on this, and this takes me to the application signals feature. Now all of a sudden I'm looking at all the service operations. These are the application layer, right? So instead of looking at it from a pure infrastructure point of view, I'm able to see from an application point of view all the different dependencies, different all the canaries that are created that are sort of hitting this endpoint and so on, all that stuff. So I mean, it makes it really simple for me to switch back and forth between different type of information in my cluster itself. And we also have a map view. So you click on this map view, you can go there and simply select a cluster. So I can select, let's say, for example, the same, not this one, the other cluster that I was looking at, this one. And you can see it actually paints a visual representation of all the resources in my cluster. You can see different namespaces here. This is the cluster, and that's a namespace, and all the different resources under that namespace, right? That includes all types of Kubernetes workloads. That's daemon sets, replica sets, and any stateful set, whatever, right? Any Kubernetes workload. And I can also select a particular node in this. This is not don't confuse this with the EKS node or anything. This is basically the node in the service map. I can select a particular one, and it will give me information about that particular node, so CPU, memory, network, and all that. And I can also go look at view dashboard, and that will directly take me to that particular service. This is essentially the same sort of operation, but I just got that in a different way, right? To this, and now I'm able to see all of this. And if you like this, right, like I said, none of these widgets were created by me. This is all automatic. But if you like this, and if you want to add it to your dashboard, your CloudWatch dashboard, you can always go click on Add to Dashboard, create a new dashboard, call it maybe test, create, and then add to dashboard. Now all of a sudden you have this dashboard available for you. In this, maybe there are some other widgets that you want to add, right? So maybe that is something that would make sense for your use case, and you can always go add other widgets, add a widget. It could be the same data source, or maybe like Bobby showed earlier, it could be that particular widget can show data from some other data source. Maybe you're also sending some application metrics to Amazon Managed Prometheus service. Maybe you want to visualize all of that in one place. You can do all of that, right? So it's quite well integrated with all the different features that we have in CloudWatch, right? Next, let's go to the next feature. All right, so Amazon Managed Service for Prometheus Collector. We are now jumping into the open source side of the house, right? So as you know, the Managed Prometheus service is a fully managed Prometheus compatible service. It's fully serverless. You really don't have to create provision any resources or provision capacity, perform auto scaling or anything like that. You simply create something called a workspace, and that workspace automatically is available for you to send millions of metrics that you want, right? So a single Prometheus workspace can support up to 500 million active time series at any given point, and you can have multiple such workspaces in your AWS account. In order to make use of that particular service, there are some things that you had to do. Take, for example, in this diagram or architecture diagram that you're seeing here. You see here that there is, if you had EKS cluster, you had to either run the OpenTelemetry collector or the ADOT collector, or maybe even a Prometheus server all by yourself, right? You have to deploy and manage that yourself, and you essentially have to you're responsible for the life cycle of that particular resource. So it becomes again, just like CloudWatch Container Insights, customers that use Managed Prometheus service really appreciated how it is easy for them to have a large-scale Prometheus solution that allows them to store Prometheus metrics in the long term, query the metrics when they want, create alerting rules, and create dashboards and all that stuff. However, they had issues with managing the lifecycle of the OpenTelemetry collector themselves, and they were concerned about, is there a way for you to make it easier for me in this, because I'm already managing a lot of workloads in my EKS cluster. I don't want to be the one that is managing the most critical workload, which is the monitoring agent myself. And if that goes down, my cluster visibility is completely out, and I don't want to deal with it. Okay, we listened to that, and we came up with, excuse me, accidentally pressed the escape button. We listened to that, and we came up with the fully managed service for Prometheus collector, which is basically a scraper that automatically scrapes Prometheus metrics from your EKS clusters. This is also serverless. You really don't have to provision any capacity. You simply create something called a scraper, and we manage the fleet of the collectors on your behalf. You can give us the scrape configuration. You can tell us what to scrape, when to scrape, and how to aggregate and all that stuff. All the Prometheus configuration is 100% fully in your control. You can give us that information, and we will use that to run the fleet of collectors for you. And we are responsible for managing that. So you don't have to own that responsibility. Here, it is you pay for what you use. There's a fee for that, obviously, and you can really monitor any AWS or EKS environment at scale. Though, how does it work? Very roughly, this is how it works. You in this case, you have this EKS cluster, and you have all these different resources here, all these pods or whatever that is. Obviously those are all workloads and that you manage, and you're responsible for that. And you prior to this, you are also responsible for managing that critical, the agent that is responsible for collecting the metrics, but now you don't have to, because with these scrapers, this is a managed scraper. So using Elastic Network Interface, or ENI, that actually gets into your VPC and scrapes the targets that you specify. And you can also specify which endpoint you want to send these metrics to. And in this case, it is the Amazon Managed Service for Prometheus workspace. All right, so let's take a look at a quick demo of how that would look like, right? If I go to my cluster, when you're creating an EKS cluster, so you can say, maybe I'm not going to create one because it takes a while, but I'm going to show you the process of like where you can actually do this. So when you're creating the cluster, you can specify this, just leave everything to default. And when you get to this configure observability wizard, all right, so here you can see that there is some language about like how you can actually use this, but you can select this send Prometheus metrics to Amazon Managed Service for Prometheus option. And under advanced configuration, you can actually give the scraper a name. This is the managed scraper that I just explained. And you can either create a new Prometheus workspace or select an existing one. Like you can select an existing one, for example, like this. And here's the Prometheus configuration. So you can actually have your own. So this is all completely editable, right? So you can, for example, I can go here. Maybe I want to add an external label with a cluster on, or maybe cluster name. I can call it webinar, right? So that, which is the name of the cluster. And if you go and create it, and it will now create a scraper with that configuration, right? So all I have to do is just next, and then review, create, and it goes through the same process. But I'll go to the one of the clusters that already have it. Like I have a cluster called scraper. You can go to the observability tab, and you can see that there is a scraper that I already have, and that is also active. And can select that. You can see the scrape configuration. So I had actually edited a little bit, like I showed in the demo earlier, and this actually sending all this to this workspace that ends with 59 FT. I can go to the Amazon Managed Service for Prometheus console, and I can check if there is a 15 FT. There's this is the one. This is the one that is receiving all the metrics from that EKS cluster, right? All right, so that makes it that basically makes it super easy for you to collect all the metrics. So now once you collect those metrics, obviously you can go create.
Amaya.
Yep.
Apologies. A couple of questions from the audience. The first one. Do you know if today is Amazon Managed Prometheus, is it able to support multiple accounts without referencing any future roadmap items, but just focusing on today, whether or not Prometheus can support multiple accounts?
Yeah, we can. That has been the case since the beginning. So it's not only multiple accounts, multiple regions. You can actually collect data from anywhere you want, not only AWS, from on-prem, from other cloud providers, anywhere you want. It's a simple answer.
Terrific. And then two follow-up questions. With regards to the scrapers, are there other destinations available for the scrapers to be used as a backend?
No, the scrapers are specifically designed to send the metrics to Managed Prometheus service.
Right. And then lastly, and I believe this is in reference to Amazon Managed Prometheus, but is Amazon Managed Prometheus limited to only EKS, or can it be used for EC2 as well?
Amazon Managed Service for Prometheus as a service, individual service, it is not limited to anything at all. You can send metrics from your own laptop, from maybe some IoT device somewhere, other cloud providers, anywhere you want, right? So, but this particular feature that I just demonstrated, that is only for EKS. That does not support anything other than EKS, because that is a Kubernetes specific component.
Terrific. And I just got a clarification. This was reference to the scraper. So the scraper is only available for EKS today.
That's correct. Yeah.
Great. Thank you.
All right. Sounds good. So now let's go. I have a I have a a Grafana workspace where I have where I logged in. Like now that I'm sending all the metrics to that endpoint, all I have to do is simply go query, right? So I can go to AWS data sources in Grafana. I see that the managed service of Prometheus is already there, and CloudWatch. These are installed by default. We will talk about this a little bit more in the next section, but it makes it super easy for you to collect or visualize, right? So as soon as I select the region, you can see that Grafana automatically tells me the different workspaces that I have. And as I showed before, the one that ends with 59FD is the one where I'm sending the metrics to. So I'm going to select that, add data source, and let me go to settings and save and test. Okay, data source is working. So now what I can do is now I can go and query those metrics, right? So I can go here, set to that data source, and I can see that there are metrics here. Now, you might wonder, like, okay, what are these metrics and how are these actually useful for me? I can query. So now you know that Grafana supports a lot of out-of-the-box dashboards, right? So there are many dashboards that are available. So I can go to the Grafana dashboards page, for example, and I can say, for example, Kubernetes, and there's one dashboard, I think it's 315 or something like that, that had a better rating. Okay, this one has a better rating, so maybe I'll select this. This one, I can copy the ID, and Grafana allows you to easily import. So I can go here, go to dashboards, and I can say new dashboard, import, and just copy paste the dashboard ID and give the data source and import. I've not imported this before, but yeah, here you go. So you have something available, right? So some data dashboard available out of the box. I think there's another one called 315, which is even better. These are all open source dashboards that that people publish, and you can actually select use any of those. But this will give you a lot of information to get going. So you can see that there's containers, services. You can see there's here's this visualization, container memory usage, or process memory usage. This so far, after creating the EKS cluster, I really didn't have to do anything other than clicking buttons, right? Pushing buttons through the interface. Just create the scraper. The scraper is automatically deployed, collecting the metrics, sending it to managed Prometheus service. And then now I come to manage Grafana and then connect to that workspace and import the dashboard, and suddenly I have visibility into my EKS cluster, right? All right. Excuse me. Now, let's go, now that we are in the Grafana space, we talk about some of the new Grafana features that we have. One of the new ones that we have is about the support for community plugins. With Grafana 9.4, as of reInvent, now we have support for...
Apologies. Apologies, Maya. Before you move on to Grafana, just a couple final questions on Prometheus.
Sure.
So the first one, just going back to the scrapers topic, can the scrapers send metrics from multiple accounts to a single Amazon managed Prometheus in a central account?
As of now, no, but as you can imagine, this is something that we do hear from customers, so we are looking into it.
Right. And then, secondly, how do you scale out Prometheus to accommodate 10,000 large EC2 instances to collect all required metrics? Any sharding or multi-tier?
Okay, so the managed Prometheus service, you don't need to do any of this. That's the most important part there. Obviously, if you're running your own Prometheus, then there are multiple things that you can do. You can have, multiple Prometheus instances. It only scales vertically, so you can probably have multiple instances, and you can actually manually shard the targets and so on. Or you can maybe use and run your own, like Cortex, Thanos, those kind of stuff. That gives you kind of scale and auto scales when needed. All of that is not needed. None of those things are needed if you're using Managed Prometheus service. You really don't have to do any of those. That's the biggest advantage there. You run the scraper in the ideal world, like, you will run the scraper, you will send the metrics to Managed Prometheus service, and the Managed Prometheus service, like I mentioned before, can support up to 500 million active time series. Even if you have 10,000 nodes, I'm assuming, 500 million is a lot. We do have, very few customers who are even getting anywhere close to it. They're really large scale customers. When I say 500 million, they're active time series, right? So your actual total number of total metrics could be higher, but active time series 500 million, and that's a good scale. That's, again, single workspace. And if that is not enough, you can obviously go create one more workspace and send those metrics there as well. But the point is, you don't have to do any of those things. Managed Prometheus service takes care of all of that for you.
And then one other question and last question before we move on to Grafana. Is the Managed Prometheus really a replacement for Cortex?
We actually run Cortex in the background. And if you are running Cortex, then you could be a good candidate to run Prometheus. So not only people who run Cortex, if you're running self-hosted, your own Prometheus server, or you're running, some other technology like Thanos or whatever, because our Managed Prometheus service is fully PromQL compatible, you can make, and also remote write endpoint is available. As long as you're able to remote write, you can send your metrics. So I think you answered, you asked if it is Cortex compatible. So we run Cortex in the background. So the answer is yes.
And last question, because I think this is relevant for a lot of folks. Is the Amazon Managed Prometheus able to manage multiple clusters?
Yeah, so it doesn't matter, like I said, where you're collecting your metrics from, right? So it could be multiple EKS clusters sending metrics to the same workspace, or a combination of EKS, ECS, EC2 environments, or maybe, third-party cloud providers. We have, we talked about it in reInvent, one of our customers, Phillips 66, who actually collect metrics from, other cloud providers into Managed Prometheus service. So it really doesn't matter. Managed Prometheus service doesn't really care or doesn't really know where the metrics is coming from, because end of the day, it exposes a remote write endpoint. As long as you're hitting those endpoints with proper authentication, it's going to take the metrics in.
Perfect. Thank you, Maya.
All right, sounds great. Thank you. All right, so moving on to Managed Grafana Community Plugin. So again, we launched this service in 2020, I believe. And ever since we launched, we have been upgrading a lot. We've added a lot of features. But one of the things that customers kept asking us about, okay, so you have 60 plugins or 70 plugins. We kept on adding plugins, but was still not enough. Customers were always asking for, well, I do have this other plugin. Without this, I'm not going to be able to use this service. Or maybe, I want this other visualization panel that I want to use, but you don't have it. Something like that, right? So we decided to support basically all plugins instead of us manually adding plugins one at a time. We decided to allow customers to they themselves go install the plugins right by themselves. And with that, what has happened is you can actually install any community plugin. So when I say community plugin, that's basically the Grafana plugin, like the Grafana Labs approved plugins, right? This is not those that you wrote a piece of code and that you have it in your environment and or anything like that. So this is something that you have submitted to Grafana Labs, and then they have, it has gone through their process, and it is available publicly for anybody to go install, right? So those plugins, and with that you have 168 data sources, 22 different applications, 130 panels like visualization options, and 24 enterprise plugins, and obviously AWS services. There are 9 AWS services that can use. So there's kind of sky's the limit at this point, right? So you can actually make Grafana do whatever you want with this, right? So let's take a look at that experience. So we are in that console. I'm logged into Managed Grafana. You can see that AWS logo there. That basically means this is Amazon Managed Grafana. And so you can we can go to plugins, and in plugins, I filtered by installed, and these are all the plugins that come along with the Managed Grafana workspace by default. And also select all plugins, right? I can see that it shows the ones that are installed and also that are not installed. Say, for example, for some reason, I'm just going to pick something, 3D globe panel. This looks like a visualization plugin that allows you to, kind of visualize a 3D globe, right? So I can go there, simply install it, and it will take a minute or so. And then once it's installed, it's available for you to use. It could have been a data source plugin, for example, and it's same thing, right? So it will take a minute, and once it is there, you can suddenly connect to a data source. Say, say for example, you were using a data source that didn't have a plugin out of the box, right? And it could be something that is not very popular, but you are using in your environment and you really needed it. All you have to do is simply go there, select the version that you want to install, and you can just go access it. So now that I have this, I believe if I go new dashboard, new panel, I believe it's a visualization panel. So let's see, 3D world or Earth. I don't know what panel it was. Okay, I forgot the name of that. But anyway, so you can see that, right? So I can actually go to like here, maybe all plugins. I can install another plugin. Says it's already installed. I don't know if it's this looks like something I must have tested before. But anyway, so this particular plugin, I don't know how specifically to use this, but you can see that it could be a data source plugin, for example. This one, right? So this is a panel plugin, but I saw that earlier. This is also a data source plugin. Yeah, and I could actually see this. It's a data source plugin. I can select the particular version that I want. I can install it, and once again, this will also take a minute or so. And once it's installed, it'll be available for me. But while it is actually installing, let's actually go take a look at how you will enable this. Right? When you go here, when you create a workspace, demo. Grafana version 9.4 is required for you for this feature, so we'll leave it at that version. And obviously, I have to use one of the authentication mechanisms. And what you have to do is you have to say turn plugin management on. So when you do this, right? So you are letting your administrators of your workspace, right, to have the ability to go deal with these plugins. And if I go to all the existing workspaces, this is one of those that I already have, which is what we are using currently. We go to workspace configurations, you can see that that's available. So the reason why I am able to use this is because I am an admin in this, and that's the reason why I'm able to kind of go add and enable plugins and so on. So if I go here, yeah, so I can see that it is already available. So it also tells me create an Anodot, I guess, data source. You'll see that this is already there. So this plugin is available for me. It did not exist. I just had to go to the, what do you call the plugin page and just install it, right? And this actually comes from here on the Grafana plugins page. You go, this is the Grafana Labs plugin page. You can actually see all filtered by different data sources and all that stuff. I believe if you search for that, yeah, there you go. So that's the one that we installed, right? So you can just go there if you anything that you want. If it's available here, it should be available on Manage Grafana as well, and you can install it, right? All right. Let's move on to the next one. All right. CloudWatch agent support for OpenTelemetry traces. All right, so this is a new feature that CloudWatch agent has gained, right? I actually went and asked Amazon Q about this. Can I use CloudWatch agent for hotel traces? And it got it 100% right. So it basically says, yeah, you can use CloudWatch agent for hotel traces. So basically what this means is, right, you had to have multiple agents before. Again, as you can see here, our whole theme is about simplifying customers' experience and making it easy for them to adopt and use and leverage the services, and make it easy for them to make sense out of their infrastructure. That's our whole goal. You can see the before and after here. The before, assuming that there is an EC2 instance, if you had, let's say, an application that is running that is instrumented using OpenTelemetry SDK, and maybe it was emitting traces in the OTel format, you had to deploy an OpenTelemetry collector, or maybe an ADOT collector to collect traces and send that to maybe your destination is X-ray. And then maybe there was another application that had that was instrumented using X-ray SDK. Yes, you can also use the OpenTelemetry collector, but you also had the option of using X-ray agent. And if you had maybe StatsD and maybe some other metrics or something like that you want to collect, or maybe even logs that you want to collect from EC instance, you have to use the CloudWatch agent to collect that. Right? You can see how this agent sprawl can become a problematic situation for customers. And now with the new option, you really don't have to do any of this, right? So if your application is collecting traces or is instrumented using OTel SDK or X-ray SDK, CloudWatch agent is just one binary that you can install, collect traces from those applications, and also collect metrics and logs and send to X-ray and CloudWatch and so on, right? So it makes it really easy for you to deal with this. That's like I mentioned, again, re-emphasizing on making it simple and easier for customers to use. Now jumping on to the OpenTelemetry side of equations. So we also have customers who use OpenTelemetry collector. So we also have this redistribution called AWS distro for OpenTelemetry, right? We call it ADOT, in other words. And that is actually a complete redistribution of the OpenTelemetry collector with specific components that AWS has contributed to, and also those that we think will make sense for customers to sort of make use of, right? And with that, that did not have log support. So any customer that had to use the ADOT collector to collect logs into CloudWatch, they also had to run FluentBit. Again, agent sprawl, customers were not entirely thrilled about having to run that many agents. Now with the new situation, you can use the ADOT collector to collect traces into X-ray, or for that matter, any destination, any OTLP supported destination. You can send the metrics to Managed Prometheus service or CloudWatch, or again, any OTLP destination. And same goes with logs. The logs component, that is a log CloudWatch log exporter that can actually help you collect logs to the CloudWatch service. So where is that? You can actually look at, go to that particular OpenTelemetry page, and you can see that this is the contrib repo, the OpenTelemetry contrib upstream repo, where we have contributed to. This is a CloudWatch logs exporter, and this has information about how you would configure this, right? So all you have to do is simply you say which log group that you want to send these logs to, and what the log stream name should be, and the OpenTelemetry collector will collect all of that. Well, okay, so it's all collecting everything, but what is the biggest thing, right? One of the biggest advantage of using OpenTelemetry itself is that you have this one binary. Okay, so what can you do with that one binary? So yes, it makes it easy for me to manage just one binary to collect all of this information. But also, because OpenTelemetry is very flexible, and it makes you sort of deal with the data much more in a much more advanced fashion. So what I mean by that is, you will be able to cross-pollinate information across these signals because you have one agent. You're collecting, let's say, Prometheus metrics from this EC2 instance. And in the same pipe, you can create a pipeline where you're taking some of the information from logs and add that to maybe a metric dimension into Prometheus metrics. So maybe that will allow you to, sort of correlate these signals much more easily, and query and troubleshoot much more faster. So the point here is that it is not only about reducing the number of agents or making it easy to deploy and maintain, but also giving you that flexibility and advantage to make more sense out of the data that you're collecting. Right. All right. So that is the end of my presentation. We actually have a lot of resources that we put out. We have a free AWS Observability course that you can take. We have something called AWS Observability Accelerator that allows you to automatically set up observability based using Terraform and CDK. This is primarily focusing on the open source side of things, like using Prometheus, Grafana, and all that. And We have a best practices guide that you can take a look at. It covers a range of topics. And we also have a hands-on workshop that you can actually go deploy in your own account, or actually, I would highly encourage talking to your account teams, setting up a workshop session so you don't have to spend any money on this and you can do everything on our dime, and we'll create environments for you and that you can actually go touch and feel and play with basically every single feature that you saw today. You will be able to actually play around with those things without you having to set up anything. We'll deploy a sample application. And in fact, everything that we showed today, all three of us, we used the applications that are part of the workshop. All right, that is that ends my session.
Oh, Maya, before you head out, one last question. Just a clarification: if the CloudWatch agent and the ADOT are the same, they are not. But if you want to add anything else with regards to the nuances between the two.
Yeah, they're separate. They're separate binaries. They're completely separate projects. CloudWatch agent is fully owned by AWS. The ADOT is an AWS redistribution of the OpenTelemetry collector that is completely upstream. We contribute to the CNCF OpenTelemetry project. It is in line with how OpenTelemetry expects things to be. While the CloudWatch agent source code is also open source, but that is not a CNCF project, or it's not like something that that has contributors from the entire industry per se, right? But while you can see that they're all converging together, right? They are supporting the open standard. So CloudWatch agent is supporting the open standard, which is OpenTelemetry, and we're enabling the OpenTelemetry collector to support CloudWatch's APIs by making it send metrics and logs to CloudWatch.
Perfect. And I'm just going to take over the screen share momentarily.
Okay.
But Maya, thank you for your time. Really appreciate it. And for everyone else, really appreciate your time here. I'm going to share a survey link. If you have time as you head out, it would be great to get your feedback on how the session went. If you have any comments or questions, that also would be greatly appreciated. But overall, thank you for the time, and feel free to get back and reach out to your account teams if you have any questions or want follow-up discussions. And then with that, go ahead and share my screen real quick. All right, so with that in mind, I'm going to go ahead and stop the recording.